wires of greater diameter are going to carry more electricity with lower resistance. Okay? Now, resistance, should have introduced resistance first. Resistance is basically how much potential difference we need to get a certain amount of current. So resistance is a measurement of volts per amps. How many volts do we need to get a set number of amps through a particular wire? So metals, more conductive, lower resistivity, lower resistance. That means I don't need as much potential difference, not as much voltage to get current through them. Insulators have a very high resistivity, which means you need a ton of voltage to get even the smallest amount of current through them. Units of resistance, they're in ohms. We use this capital Omega as a symbol for ohms. They're named after Charles Ohms, who did, George Ohm, who did some work on measuring how the potential difference would change as a function of current. He came up with Ohm's law, which is the next section. And basically, the ohm, as we saw before, is just how many volts we need per amp. Number of volts per amp. Again, those are your SI units for resistance. These are precision resistors. These are actually precision resistors where they've scraped off the outer coating of this. And under most conditions, if they're operated properly, these will always give a very set amount of ohms. So we can design different circuits to behave in a very specific way because they accurately resist the flow of current based on some voltage. So these resistors, we'll see a lot of time in printed circuit boards. You'll see these funny things with different colors. And they don't just paint them to make them look pretty. There's actually a purpose. There's a coating that they use for this. The first two bands are used for what are known as the units. The third band is the power. The last band is what's used for what's called tolerance. And we'll talk a little bit about that in a bit. But here's some of the different resistors. Again, as long as we don't put too much power through them, like these are the ratings in power, they operate just fine. As the power gets greater and greater through these, we have to go to larger and larger structures. Here's a 10 watt resistor, a 20 watt resistor, and it can just get bigger and bigger. High power resistors, actually, you'll see high power resistors have heat sinks on them. This gold high power resistor has a heat sink on it. These fins radiate heat much more efficiently. They actually conduct heat to the air, and through convection, they'll self-cool, they'll passively cool. And this power resistor is actually on an even bigger heat sink. So due to the large thermal outputs, if we're talking about many watts of heat, that can overload a circuit rather quickly. We've got to dissipate that heat before it does any damage. A lot of the parts of the printed circuit board can't take high temperatures. Even the solder that holds things together will melt after a certain temperature. But again, heat sinks used to dissipate the electrical energy. So these are the resistor codes for resistors. Again, the first two digits are represented by these first two stripes. Then we use what's called a multiplier, which is basically a power of 10. And then again, the last one is tolerance. So this resistor has red, black, green, red for 2, black for 0, so it's 2, 0, and then the green is a multiplier. Green is 5, so it's 10 to the 5. So this is a 2 times 10 to the 6 ohm resistor, or a 2 mega ohm resistor. Now the band right here is silver. That silver indicates a tolerance of 10%. That means that the manufacturer guarantees plus or minus 10%, which means that it is guaranteed to operate with resistance between 1.8 mega ohms up to 2.2 mega ohms. Here's another one, green, blue, orange, gold. Here it's 5, 6, 56 times 10 to the third. Orange is third, or 3. And then this is a gold band, so it's guaranteed to operate at a 5% tolerance, which means that this particular resistor, got to do my math here, is probably good from about 53 ohms to about 59 ohms. You can expect it to operate pretty well there.